India's Chandrayaan-3 mission has captivated the world with its groundbreaking discoveries since it successfully landed on the Moon's south pole last year. The data returned by the Pragyan rover has revolutionized our understanding of the Moon's ancient history. Among the most significant findings is the discovery of an ancient crater located near the mission's landing site, a 160 km wide impact crater, nearly 3.85 billion years old. Imagine standing on the Moon and gazing down at this colossal crater, a remnant of an era long past, its secrets now being uncovered by scientists. What would this ancient crater reveal about the Moon's earliest days, and perhaps even about the origins of our own planet? The findings present an unparalleled opportunity to unlock answers to these questions. These remarkable discoveries provide vital insights into the formation and evolution of the Moon, and offer a fresh perspective on the early days of our solar system. Recent analyses conducted by scientists from the Physical Research Laboratory and the Indian Space Research Organisation, ISRO, suggest that Chandrayaan-3's Vikram lander made contact with a buried impact crater about 10 to 60 km in diameter and 4.4 km deep. This crater is believed to date back to the Nectarian period, a time that occurred approximately 3.85 billion years ago. During this period, intense asteroid bombardment shaped the lunar surface, leaving behind large craters and altering the Moon's geological makeup. This discovery makes the crater one of the Moon's oldest, providing an invaluable opportunity for scientists to study one of the earliest lunar formations. The Nectarian period was marked by massive asteroid impacts, which also affected the early Earth, giving researchers a rare chance to study a preserved environment that mirrors the Earth's own chaotic beginnings. While the Earth's surface has been reshaped by tectonic activity, weather, and erosion, the Moon's static environment has allowed its surface to remain unchanged for billions of years. As a result, the Moon serves as a unique laboratory for studying the early solar system. The Pragyan rover, deployed by the Vikram lander, played a pivotal role in capturing critical data from the surface of the Moon. It conducted on-site observations and sent back detailed images of the area, revealing unique geological features that had never been seen before. These images depicted the presence of ejecta, material thrown out by impacts from other craters located further away, indicating that the landing site contained a mixture of material from various parts of the Moon. This discovery is significant because it shows how material from different lunar regions has been mixed together over billions of years. By analyzing these samples, scientists gain valuable insights into the geological processes that shape the Moon's surface. The ability to study such diverse materials at a single location is a rare opportunity in planetary science and could help answer fundamental questions about the Moon's internal structure and composition. The newly discovered 160 km wide crater is not just another lunar feature, it represents a geological treasure trove. Its size and depth make it one of the most significant formations found on the Moon, and its study could offer clues to the Moon's past. This crater, formed during the Nectarian period, is a relic from a time when the Moon was being bombarded by asteroids, much like Earth was. These violent impacts left deep scars on the Moon's surface, and studying these ancient structures helps us understand the processes that govern the early solar system. The Nectarian period, occurring more than 3.8 billion years ago, was one of the most tumultuous times in the Moon's history. Asteroids and comets bombarded the Moon's surface, forming massive craters and creating a lunar landscape vastly different from what we see today. Understanding the composition of materials from this period will allow scientists to reconstruct the geological history of the Moon and determine how it evolved over time. Studying the Moon provides more than just information about its own history, it offers a window into the broader history of the solar system. By analyzing ancient lunar materials, scientists can glean insights into the conditions that existed during the early stages of planetary formation. When the solar system was forming, moons, planets, and asteroids collided and merged in a violent process of cosmic creation. These collisions left behind records of the conditions that existed at the time, conditions that are still preserved on the Moon. The Moon's lack of an atmosphere, tectonic activity, and erosion has helped preserve its surface in a way that Earth's surface cannot. The lunar surface is essentially a time capsule, offering a glimpse into the early solar system. The presence of ejecta at the Chandrayaan-3 landing site provides an even more intriguing opportunity to analyze how the Moon's surface was shaped by impacts from various sources. The ancient impact crater is essentially a time capsule. It preserves materials from a time when Earth itself was undergoing similar asteroid impacts. Unlike Earth, which has undergone constant geological changes, the Moon's surface has remained relatively static, providing a perfect record of early solar system history. The presence of these ancient materials allows scientists to study the processes that shaped not only the Moon, but also the Earth and other planets in the solar system. One of the key questions scientists hope to answer through the study of this crater is how the Moon formed. Many scientists believe that the Moon was created when a Mars-sized object collided with the early Earth, ejecting material that eventually coalesced into the Moon. By studying the composition of the rocks and soil from the ancient crater, scientists may be able to uncover evidence supporting or challenging this theory. This could be one of the most profound discoveries of the mission, potentially altering our understanding of the Moon's origins. The implications of this discovery extend far beyond the Moon. Understanding the geological history of the Moon offers clues about the early Earth, as both bodies were subjected to similar processes during their formation. In addition, the study of lunar geology provides insights into the broader processes of planetary formation and evolution. By examining the composition of materials from different lunar regions, scientists can gain a better understanding of how celestial bodies like planets and moons form, evolve, and interact with each other. In particular, this discovery could offer important clues about the potential for life beyond Earth. The early stages of the solar system were characterized by extreme conditions, including frequent asteroid impacts, intense radiation, and volatile environmental conditions. By understanding how the Moon's surface was shaped during this time, scientists can make more informed predictions about the likelihood of life on other planets, particularly those in the habitable zones of distant stars. The Chandrayaan-3 mission has opened new frontiers in lunar exploration. Its discoveries, especially the identification of the ancient impact crater, provide a rare opportunity to study the Moon's geological history and its role in the early solar system. By uncovering the secrets hidden beneath the lunar surface, scientists can reconstruct the processes that shaped the Moon, the Earth, and other celestial bodies. As we continue to study the Moon and its mysteries, we are not only learning about our closest celestial neighbor but also about the history of our solar system and the origins of life on Earth. The Chandrayaan-3 mission has propelled us further into the unknown, offering a deeper understanding of the Moon's history and its role in the broader story of the universe. This journey is far from over. As new missions like Chandrayaan-3 continue to explore the Moon, we can only imagine the groundbreaking discoveries that await us. With each new finding, we come closer to unlocking the mysteries of the Moon, our solar system, and the universe itself. India's space exploration journey has been marked by numerous milestones, with the Chandrayaan missions being among the most significant. These missions have not only increased India's presence in the field of space exploration but have also contributed immensely to global knowledge about the Moon. Let's dive into the history of the Chandrayaan missions, exploring their evolution, the challenges faced along the way, and the major milestones that have made India a key player in lunar exploration. India's first venture into lunar exploration was launched on October 22, 2008, by the Indian Space Research Organisation, ISRO. The mission's primary objective was to survey the Moon in detail, mapping its surface and mineral composition. One of the most groundbreaking findings of the mission was the discovery of water molecules on the Moon. The Moon Mineralogy Mapper, M3, aboard Chandrayaan-1, a payload developed by NASA, found evidence of water molecules in the Moon's polar regions. This discovery changed our understanding of the Moon and opened up new possibilities for future lunar exploration. The mission provided comprehensive maps of the Moon's surface, helping scientists better understand its topography and mineral composition. This data was critical for planning future missions. The success of Chandrayaan-1 proved India's capabilities in launching sophisticated space missions. It marked India's first mission to the Moon and helped ISRO solidify its reputation as a reliable space agency. Unfortunately, in August 2009, contact with Chandrayaan-1 was lost after a series of technical malfunctions. Despite the early termination of the mission, the data collected was invaluable and contributed significantly to lunar science. Chandrayaan-1 was a relatively small mission with a limited budget, which posed constraints on the scope of its objectives. However, The mission's success demonstrated that even with modest resources, ISRO could achieve significant results. After the success of Chandrayaan-1, India embarked on its second lunar mission with the goal of expanding the scientific knowledge gained in the first mission. Launched on July 22, 2019, Chandrayaan-2 aimed to achieve more ambitious objectives, including a soft landing on the Moon's South Pole region. Unlike its predecessor, Chandrayaan-2 included three components: an orbiter, a lander, named Vikram, and a rover, named Pragyan. The orbiter's primary mission was to study the Moon from orbit, while the Vikram lander was designed to make a soft landing on the Moon's south pole, with the Pragyan rover to explore the surface. The orbiter carried scientific instruments designed to study the distribution of water ice in the permanently shadowed craters at the Moon's south pole. This was one of the main objectives of the mission, as finding water ice on the Moon could have significant implications for future human exploration. The orbiter's instruments also analyzed the Moon's surface composition, mapping its elements, minerals, and topography with high precision. Although the Vikram lander made an unsuccessful attempt to land on the Moon in September 2019, the orbiter continued to function, sending valuable data back to Earth. The orbiter's success proved critical for the mission's overall success. The biggest setback of Chandrayaan-2 was the crash landing of the Vikram lander. It lost communication just moments before its soft landing on the Moon. This was a major disappointment for ISRO and the global space community, as the soft landing on the Moon's south pole was one of the key milestones of the mission. The failure of the Vikram lander highlighted the complexities and challenges of landing on another planetary body. The technical difficulties involved in landing on the Moon's rugged terrain, particularly near the South Pole, were far more challenging than anticipated. As with Chandrayaan-1, Chandrayaan-2 faced some budget constraints, but the mission still showcased India's increasing capability in space exploration, as it was one of the most complex missions ever undertaken by ISRO. Building on the lessons from Chandrayaan-2, was designed specifically to achieve a successful soft landing on the Moon. Launched on the mission aimed to overcome the challenges faced by its predecessor and successfully land near the Moon's south pole. After the setback of Chandrayaan-2, Chandrayaan-3's major goal was to achieve a successful soft landing on the Moon. The Vikram lander, this time equipped with advanced technology, successfully landed on August 23, 2023, making India the first country to successfully land near the Moon's south pole. This achievement was a significant milestone in both ISRO's history and global space exploration. The Pragyan rover, designed to study the Moon's surface, conducted in-depth analysis and exploration of the lunar terrain. It sent back images and data that have provided critical insights into the geological history of the Moon. One of the most notable discoveries made by Chandrayaan-3 was the identification of an ancient impact crater, 160 kilometers in diameter and approximately 3.85 billion years old. This discovery provides a rare glimpse into the Moon's early history and offers valuable information about the early solar system. With this successful landing, ISRO proved that it could overcome the technological hurdles faced by Chandrayaan-2. The mission solidified India's position as a global leader in space exploration, demonstrating its ability to conduct complex interplanetary missions. The lander and rover underwent extensive testing to ensure that they could withstand the harsh lunar environment. The technical challenge of landing on the Moon, particularly near the South Pole, posed a significant risk. As with previous missions, Chandrayaan-3 faced budgetary constraints, but the efficiency and planning by ISRO ensured that the mission was carried out successfully within budget and on time. ISRO's Chandrayaan missions have steadily evolved, with each mission building upon the successes and lessons of the previous one. With success, the stage is set for more ambitious lunar missions in the future, including the possibility of human exploration of the Moon. ISRO is already planning future missions that aim to continue exploring the Moon's south pole and its potential resources. These missions could involve more advanced rovers, long-term lunar surface exploration, and possibly even the establishment of a permanent lunar base. The Moon's south pole is considered one of the most promising regions for future lunar exploration. The discovery of water ice could lead to long-term human missions to the Moon, and Chandrayaan-3's findings provide a crucial foundation for these future endeavors. ISRO is increasingly collaborating with other space agencies, including NASA and ESA, European Space Agency, to share data and work together on future lunar missions. The next wave of lunar exploration could see a global effort to return humans to the moon and establish a sustainable presence there. From Chandrayaan-1's historic discovery of water on the moon to the successful landing of Chandrayaan-3, ISRO has made remarkable strides in lunar exploration. The missions have faced numerous challenges, but each one has contributed valuable knowledge and experience to India's space program. As ISRO looks ahead to the future, the Chandrayaan missions will continue to play a crucial role in understanding not just the moon, but also the broader history of our solar system. With each new mission, India's space capabilities grow, promising even greater achievements in the coming years. Please like, share, subscribe and comment. Thank you for watching my channel.